All right, so welcome back to part two of your trig review video. Now, a couple of things that, kind of to review, how would you have done each of these problems? If you're taking a look, say here at the sine of pi over 3, I do want to remind you when you're doing the reference angles and kind of taking a look at that there are reference angle formulas. That when you're looking at quadrant 1, you can think of that as always your reference angle. In quadrant 2, every angle that has the same terminal point as this one reference angle, except you're in quadrant 2, is going to be found by doing pi minus the reference angle. If you're in quadrant 3, you would do pi plus the reference angle, and in quadrant 4, 2 pi minus the reference angle. So the first thing that you're going to do at any given time when you take a look at trying to find the trig function for an angle is you should figure out what quadrant you are in and what family you are in, and then that will help you know what your terminal points are. So usually you just have to memorize the first quadrant of the unit circle. So here with sine of 5 pi over 3, what I know is that I'm looking for the y coordinate on the unit circle for the pi over 3 family. And how I know it's the pi over 3 family is because 5 pi over 3 is equal to 2 pi minus pi over 3. 2 pi is 6 pi over 3 minus pi over 3, 5 pi over 3. So once we figure out our family, so we're like, hey, I'm in the pi over 3 family. I'm looking for the y coordinate, and then you just pretty much have to memorize that for the pi over 3 family on the unit circle, if I think about what's going to be up here, it has a x coordinate of 1/2 and a y coordinate of square root of 3 over 2. And so basically all I have to worry about then is, hey, this was in quadrant 4, which is going to be the plus minus quadrant when you're down here, and the sine is the second or the y coordinate, so it's negative. So the answer to this should be negative square root of 3 over 2. So that's kind of how you work through your trig ratios, where you don't have to like memorize everything, you just have to memorize a few of them. And I'm going to show you the answers to these here in a second, but the other thing that's kind of important to know is what happens if you're not between 0 and 2 pi, which is when you're looking at the unit circle over here, all of these angles, and in calculus we do stay in radian measurement, we don't use degrees at all, we're going to be between 0 and 2 pi, kind of coming around here in this outside edge. Don't worry about the degrees, know the radian measurement, because that's the most important thing. What if you are not between 0 and 2 pi? Well, then we'll remind you that your coterminal definition, a coterminal angle is any angle that ends in the same spot, has the same terminal point, and hence the same trig functions, that you simply add or subtract multiples of 2 pi. So if alpha and beta are coterminal, if you add 2 pi k, get that out of the way, multiples of 2 pi to beta, you should get alpha. So if you're looking at the angle that you have given here, and if that angle is not between 0 and 2 pi, I would go ahead and find the coterminal angle that is, and then do your trig functions based on that, because you can use your reference angles. All right, if you flip over to the next page, you'll see up here are all of your answers that you should have gotten. So go ahead and check and see how you did. And notice we've got a D and E. When you're looking at, say, the cosecant of pi, just to kind of talk a little bit more about that, pi, of course, is located over here on this side of the unit circle. It has the coordinates -1, 0. And cosecant is the reciprocal of sine. Sine's the y coordinate. And so the reciprocal of sine, because technically you're 0 over 1 because your radius is 1, right? That's going to be your opposite over your hypotenuse, sine of pi. So sine of pi is 0. So cosecant of pi is 1 over 0, and we have a division by 0 problem, which is undefined, hence does not exist. And then, of course, when you see something like this, this creates a vertical asymptote on the trig graphs when you take a look at those. All right, now the other thing that we wanted to do here, kind of some things, I don't really have them in these notes, but you should definitely go back and look at the actual graphs of the sine wave, the cosine wave, your tangent function. Those would be the three most important, and I would probably also look at your secant. technically when we did trig functions, it's actually sine and sine, tangent, and secant are actually the three main trig functions, even though I know we did sine, cosine, and tangent, but sine, tangent, and secant, and then the other three are what are called co-functions because the cosine is the sine of the complementary angle, complementary sine, cosine, where you've simply complementary angles just switch the x and the y coordinates on the unit circle. Like if you look at your pi over 6 and your pi over 3, they're complementary to each other, 30 degrees and 60 degrees, and notice you've simply switched your x and your y. So it just switches sine and cosine for those functions. All right, so let's do an actual problem where we're using our trigonometry. So over here in example 1, what we're going to do is, let's take a look at it. We've got to find all the remaining 5 trig values given a sine, and they also tell you something about cotangent. Now they're giving you both of these because you actually need at least 2 pieces of information to determine what quadrant you're in. So we're going to use that to figure out our quadrant so we know the sign, SIGN, and then we're going to use that and find our trig ratios. So that's part 1. So let's kind of pause there and let's do that first. So let's go. I like to draw pictures. That's always good. So I would draw this and then I would start thinking about what quadrant I'm in. So sine is negative, which means that you have to be something and then we'll put question mark, and then there's a negative because sine's the y coordinate. This only happens if you are in quadrant 3 or quadrant 4. So my target right now, just put a little dot here and here. I'm in one of those 2 quadrants based on this information. Then I look over here and I say, all right, cotangent is positive. Now, cotangent's one of the reciprocal functions, and our mnemonic had to do with sine, cosine, and tangent. So I would immediately go, well, if cotangent is positive, then so is the tangent. So tangent is positive. And if we go back to our all-star trig class, all students take calculus, then tangent is positive only in this quadrant. So we have to be in quadrant 3. So the first decision you're going to make is what quadrant are you in? And that will give you information about the signs of all the rest of the trig functions. Then what I basically do is I like to draw the triangle, but there's different ways. You can memorize your unit circle. You can do different things. This is not necessarily a unit circle, nice reference angle because it's -3/4. It's not one of the ones on the unit circle. But what I do is I come here, you always draw your reference angle and your reference triangle to the x-axis, never to the y, always to the x-axis. And then we know that the sine, if we do SOHCAHTOA, is always opposite over hypotenuse, or in terminal point definition, it's y over r. So when you have this negative, you know that the r is never negative, r is always positive, so it's going to be opposite is -3, the y, and then the hypotenuse is going to be the radius, or 4. So we have a -3 and a 4. Now you might be tempted to go, hey, the other side's 5, but remember that's when the hypotenuse is 5. To find the third side in the triangle, you're going to come in and you're going to do basically unit circle Pythagorean identity. So I know that -3 squared plus whatever the x is squared is going to equal 4 squared. So we're essentially just going to solve for our ratio. 9 plus x squared equals 16. Subtract your 9. X squared equals 7. So x equals, now for solving, technically it's plus or minus square root of 7. But if you are in quadrant 3, this is the minus quadrant, so it is negative square root of 7. So we get our third side in the triangle, and then we can answer the question of what are the remaining 5 trig values. Our cosine of theta is going to be x over r, so negative square root of 7 over 4. Tangent of theta, opposite over adjacent, which 2 negatives make a positive, 3 over square root of 7. Now, while I'm here, I will talk about rationalizing. You are not required to rationalize in calculus. We don't care about arithmetic. This is a perfectly valid answer and will be accepted. You could also rationalize and say 3 square root of 7 over 7. We don't care about that. That's perfectly fine too. But you don't, it's unnecessary. If you're in multiple choice, of course, if this is an answer and that's not, you have to recognize that those are the same, but you're not required to do that. And then, of course, our reciprocal functions, you should be able to go through. The reciprocal of sine is cosecant. And so the reciprocal of -3/4 is -4/3. Your secant reciprocal is going to be reciprocal of cosine. So 4, -4 over square root of 7. And your cotangent is reciprocal square root of 7 over 3. And so there are your trig functions. Right, now taking a look at the next thing that they're asking in this problem. So we want to find theta such that theta is between 0 and 2 pi. And then they ask for the reference angle. I actually do those two things together because to find theta, I actually pretty much always find the reference angle first. So what I would suggest is that when you look at this, we've got the sine of theta is -3/4. I always think of that as saying sine of theta in quadrant 1, or maybe instead of theta, let's come back in here. And let's say sine of the reference angle is going to be 3/4. So if you keep that in mind, because remember your calculator is set up to only return an answer in the principal value range, which was the restriction that we had. And so if you always just do the reference angle, then you don't really have to worry about what restriction the calculator is using. So what I would do is I would type into the calculator, because this is not going to be a special nice unit circle angle. I would type in inverse sine of 3/4. And so I pretty much will always convert whatever you're given up here, either sine, cosine, or tangent, and I do it for the reference angle. And we're going to type that in, and we'll figure out approximately what that is. All right, so I pulled my calculator up, and as you can see here, the first thing you want to check is that you want to be in radian mode. And then I'm going to go to my home screen. So I'm going to quit to the home screen, and then we're going to do the inverse sine, which is right above the sine. So the inverse sine of 3/4. And so that is going to give me approximately in radians what my angle is. And in calculus, you are always going to round to 3 decimal places. So 0.848. So let me minimize that. 0.84. Let me put myself up here again. 0.848. Then to find theta, now I go to the reference angle formulas that we talked about earlier. In quadrant 3, I need to do pi plus the reference angle. So I am simply going to add pi to that on my calculator. So I pull that up, plus pi, and then that will tell me what theta is. 3.98, or it's going to round 3.990. 3.990. And then we have our angle theta. And so that's why you have to know what quadrant you are in. You have to know that you're in quadrant 3, so you know what formula you're going to use to find the angle between 0 and 2 pi. All right, and then the last thing in this one before, because I have 15 minutes and I'm going to run out of time, is that what other angle has the same sine value? So now what that is we're looking at quadrant 3 where sine is negative. And so what we need to do is we need to determine if we have a negative sine value, where else are we negative? And sine, the y-coordinate, is also negative in quadrant 4, which is 2 pi minus the reference angle. So our other angle, we'll call it alpha in this problem, would simply be 2 pi minus the reference angle. So we'll run really quick back to my calculator, and we'll do 2 pi minus the reference angle. And you can remember your little calculator uses. I can just come up and grab that right there, put it in, hit enter, 5.435. So we'll add that as our answer, 5.345. I think I wrote it down right from what we just had. Yeah, 435. All right, so that kind of gives you a little overview of some important things that you need to remember about trigonometry and working problems. Now, we'll talk in more detail in another video about the inverse operation, inverse functions and solving. So I'll come back in, we'll do part 3 of our little video and work on that.